So my name is Burcin Becerik Gerber, and I'm an associate professor in the Civil and Environmental Engineering Department of USC. And I direct a lab that focuses on responsive and adaptive intelligent environments with a specific focus on human-building interactions. So what I'm interested in, the buildings to be more responsive and responsive to human needs. At the same time, those needs can change, and I would like the buildings to be more intelligent and through time understand human needs and adapt to those needs without humans prompting the needs or talking about their needs or communicating the needs to the building. So that's where the intelligence comes. So it's not just like as a user of a space, I have a need and the building responds to it. For example, there's glare and it closes the blinds. But at the same, so it's not just that, but the building understands what the lighting levels that I'm comfortable with or what the lighting levels are good for me in terms of my well-being at the moment of time, depending on the tasks that I'm undertaking, and adapts to those needs. So that's where the responsiveness and adaptiveness come from. So there are several variables that we can impact. There are environmental variables such as lighting, and it's both illuminance as well as the color. There's thermal properties that we can influence, air temperature, humidity, relative temperature, radiant temperature. There are other things that I would like to think about buildings as not static, so it's a little bit non-traditional maybe, but I would like to also think about buildings where they change color, the materials, so it doesn't have to be just the static buildings that you're thinking about. There's air quality that we can influence, of course, which is very important in terms of your health and well-being, productivity, mood, and all that kind of good stuff. There are other things that I'm really interested in terms of interaction, right? There's several means of interactions that happen between buildings and humans, and buildings and their users. So I'm interested in more intelligent furniture, more intelligent building systems, like heating, cooling, air, ventilation, or lighting, as I mentioned. And more intelligent building objects or components like the blinds or the doors or the windows. So I see a building as a system. So I would like that system at different subsystem components to be adaptive and responsive. Is that true that many people don't think or are not bothered by static buildings? I'm not sure about that. But I'll give you examples. I think space really influences who we are and our mood and how much we want to be in that location or not. There is quite a bit of research specifically focusing on office buildings and how space design, space organization, privacy, attributes of the space creates, for example, absenteeism, because people don't want to be in certain type of buildings. They prefer to be in another type of space or outside, or their productivity is affected, or their feelings of happiness is affected. So you might not maybe as a user consciously think about these things every day or every moment, but you might be experiencing the negative effects of a space that is not meeting your needs. I think it's the type of thing that we're not used to having, right? Once you have it, then you just like cannot be without it. I mean, without the smartphones, we didn't feel like there was a lack of a smartphone in our lives, or without Alexas or Siris or similar devices. But now they become part of your life. So if I lose my smartphone, I wouldn't know where my next appointment is, where to go, and how to get there. So I think technology becomes our life, or becomes part of us as we get more acquainted to it. So most of the buildings are built for humans. There are a few buildings that are not occupied by humans, but very few. So for me, if we are, and Americans, I'm sure you know, spend almost 90% of their time indoors. So for me, if you're spending so much time in a man-made space, it has to be centered around your needs. So depending on the space type, okay? So if you're in a classroom in a higher education building and the main mission there is the teaching and learning, the space has to be built around, designed and constructed and operated around the students and the teachers, from my perspective. If it's your home, obviously you and your family, and if it's your office, you and your colleagues. So I'm interested in these spaces not to be just boxes that you occupy, and these furnitures, like the chairs that you sit on, but they respond to your needs at the moment that you have those needs. And those needs change, of course. They're not also static, so I might be feeling happy, I might be feeling stressed, I might be sick one day, I might I'm healthy most of the days. So depending on how I feel, and the space has to respond and adapt. Sorry, I'm repeating myself quite a bit. No, and in most buildings, we don't have this, right? Most buildings are designed for standards and codes. So, so there is one set point in terms of temperature set by the facilities management, like 73 Fahrenheit degrees. And it doesn't matter if it's you occupying my office or if it's me occupying my office, if I'm sick or healthy, you would just find that optimized temperature set point. But I'm thinking, if I'm spending so much of my time in this space, then it has to be based on my needs. I mean, no, I think you have a point there. I mean, it is very technologically focused, but also taking us to our roots, right? It's not, so what I see my work is not just implementation of technology for the sake of implementation of technology because it's cool or popular. But use of technology for the human good. So that's how I see that. I see technology, or I would like to see technology as an enabler for better life or higher quality of life than something that is deployed just because. There's one project I'm working on, and is focused on creating this intelligent workstation. And this is a desk that this is highly censored. We have it in the lab, and I can show it to you if you want. And it senses all kinds of variables in space, including temperature, lighting, occupancy. We have thermal cameras that would basically sense your skin temperature. We have wearable devices that users of that desk use. But the idea is not just sensing, okay? The idea is taking that information and making sense out of that data, which is related to your preferences. Because we know that it's not like one size fits all kind of situation here. Some people prefer milder temperatures, some people prefer cooler temperatures. And this depends on our gender, it depends on our health, metabolism, it depends on our cultural background. So there are various reasons why we prefer one temperature over another, and it's usually a range as well. So, so Americans have a very narrow range of comfort. Asians have a much wider band of comfort, and we learned through research that the wider the ranges, the better it is for your health. So again, coming back to this intelligent desk, this desk senses the environment as well as you physiologically as well as psychologically, and models your preferences. And the idea is not only to provide comfortable environments that you feel satisfied, but if that range is not optimal or not good for you, negotiate with you to change your preferences towards healthier conditions. So that's where the difference that I want to make. Something that we prefer might not be necessarily good for us. And if we have that level of intelligence in a building or in a space, how a building can work with you to take you to a healthier or more productive or eventually a happier condition is of my interest. And it's a very interesting research question, in my opinion, because now we're talking about something like a desk, which is a very mundane office object, working with a human being to change the person's preferences. And it's a negotiation, of course, right? And in some cases, it could be because of a health objective, or it could be related to an energy objective, right? So depending on the building's objective as well as the person's objectives. But that negotiation and that conversation between a thing and a person is very interesting from my point of view. They might be conflicting, all of these goals. You're right, and it gets a little tricky when we talk about those goals, but from whose perspective? So, as you mentioned, productivity, from whose perspective, right? Is it from the employer's perspective or employee's perspective? So what about, like, I prefer an environment that is a lot more comfortable for me, but energy-wise is very costly. So it is a trade-off, like everything else in life. I think if we can compute that trade-off, we can make more informed decisions. And from my perspective, I think first and foremost, the users of the space should have a say. And it gets into a little bit of privacy concerns as well, because if you are working in an environment that is highly monitored, and if I can look at your activities and how fast you're typing and where you're looking at and how much time you're spending on different tasks, then I might be able to tell which employee is more productive. But I mean, if you have short-term goals, I think there needs to be a balance between short-term and long-term goals, right? I mean, you might be saving energy today, but what does that do to your health? And what is more important for you, right? Is it instantaneous productivity that you're after, or you're interested in your employees to be healthier over a long period of time, or more productive or happier? So we have to really, I think we have to use this data that we're collecting to inform in a way that would inform us to make better decisions. So I think what is important, I mean, in terms of autonomy, there are two different concepts that I work on. One is adjustable autonomy. So it is basically the level of automation changes based on the person and person's preferences. And this also, it's a very individual based also, it's very task based, or they're situational and temporal conditions that also change that autonomy preferences. So for example, I might be okay with you automating lighting and temperature, but I might not be okay with you automating my devices. So there could be different levels of autonomy that is assigned to different devices and different conditions, as well as different users, right? And then if we have the right amount of intelligence, this autonomy could be progressively increased or decreased, so that gets into progressive autonomy. So you can start with something less autonomous, but get comfortable with it and understand the benefits to you, and then increase that autonomy in time, or you become uncomfortable and you basically decrease that autonomy. If you think about current buildings, actually, you have very little autonomy. You have more autonomy in your home, but as you get out of the home context, you have very little autonomy. You cannot decide on the size of the windows or how much light comes into your space. You don't have much autonomy in terms of what type of lighting fixtures or what type of lighting color you want. In some cases, we don't even have autonomy on the furniture. In a way, I would like to think my research brings more autonomy to people. This is the goal, at least. So in this one project, we were very interested in basically giving a voice to the building, because in some cases you can satisfy people, but in some cases it's counterproductive to do what humans want all the time. As I mentioned, there could be an energy consequence, there could be a cost consequence, there could be a health consequence. So we were thinking about, like, what if we cannot do what the users want, and we have to communicate with the user and explain the reasons, or request the user to do something different than what they're intending to do. So we did this research and we personified the building, and we tried different things. We tried to approach the user through text, through voice, and through a virtual agent. And in all these three cases, we had a female and a male version of the building. It was very interesting, as you might have guessed. The virtual agent gained more acceptance than the voice itself, than the text. And then in all of the cases, the female voice or the female agent was more successful in convincing people to do the right thing, or what was requested by the building agent. So that was interesting in the sense that you know, in your navigation or in your phone, there's a female voice, and now they're working on a genderless voice. But we weren't sure if this would carry forward for a building context. The other interesting finding in that research is, in one group we said, is the building going to approach you? In the other group we said the building manager, facility manager, is going to approach you. And in that particular research, when people thought it's the building manager requesting something from the user, they were more compliant than the building. So we were really interested in understanding if repetitive interactions with this agent is going to help with compliance or hurt the compliance. To my surprise, the more people interacted with the agent, the more they complied with the agent. This was a question that they didn't predict the answers to be as such. And I want to extend this research because if we were to be interacting with buildings or agents of buildings, it has to be, we have a lot more research to do, because there are many situations that we might want to interact with an agent, or we want no interaction or no interruption. And when this agent is interacting with you is another question, right? I mean, if you're in the middle of a very important task that you're concentrating, okay, maybe compliance rates are going to be very different versus if you're in a casual conversation in a meeting, that's completely different, or by yourself reading a piece of paper, so it's very different, right? So when to interact with the human user and how much to interact with the user, and to know when and how to approach the human user are, in my opinion, are all open and very interesting questions. But it's not really fake. I'm not sure. I mean, yes, emotions, the buildings don't feel pain or sickness. But buildings have personalities as well. I mean, buildings have needs as well. I mean, as an engineer, you can set goals for a building in terms of its safety, its energy consumption, different factors. So it could be, so those could be the factors that they present their emotions to the persons, right? So if you're very energy conscious, for example, pro-environmental, if the building basically tells you that your actions are creating more sustainability problems or more consumption of energy and explains to you why, I see that as a positive outcome. I think, I mean, it is a legitimate concern in terms of the data being collected, but I think the answer to that is who controls the data. And in my opinion, a person controls his or her own data, right? So I might request to be in a building or in an office where, you know, it's lifeless. Nothing is controlled, nothing is monitored, like today. But if there are any benefits to me, and if those benefits are proven to me, I might decide which data points that you can use or the building can use and to what extent, okay? So as long as I have that decision-making power, I don't see much of a problem. I think the problem is if I collect data from all of the users of this building and use it to report it to the employers and say that, I don't know, Jake is 50% of the time here, but Arthur is like 100% and working overtime. So that's a completely different story, right? I'm not, so again, I think that the answer there is it's not the data that makes it dangerous or concerning, is how people use that data. So a good example is thermal comfort. We have different methods, and we have compared different methods to compare different models that we have built. For example, physiological response-wise, we have created these devices that you can wear. They're thermal imaging sensors attached to it. It's an eyeglass, and we collect skin temperatures from different points on your face. Recently, we have looked into thermal imaging, so you don't have to wear something. It's just basically taking your thermal image. Where we look at sweat, we look at heart rate. From all of those physiological data, at the same time we collect psychological data, right? So, are you comfortable with the temperature? Are you feeling cold, or are you feeling cool or warm or hot? But also, feeling comfortable does not necessarily mean you're satisfied. So at the same time, we collect satisfaction data, because I might be feeling cool but satisfied, or I might be feeling cool and not satisfied. So that's also really important. There are nuances there. And we use the subjective data which is the psychological data. And I say subjective because it changes, right? People change their mind at the same degree temperature, 73. Sometimes you're cold, sometimes you're hot. We correlate, we use mathematical models to correlate that to the physiological objective data. And we can tell that without, so that's the psychological data is our ground truth. But once we train our models, we can take that ground truth and just look at the physiological data to be able to tell if you're feeling thermally comfortable or not. But then there is something very interesting, which is the mind reactions to the body's reaction. There's a good match there, but your body could be off or your mind could be off, right? So one good example is when you're sick. So those might not match, or when you're feeling stressed, those might not match. Okay, if everything goes as planned, I would like us to be in a place where buildings become your best buddies. So maybe that's scary to some people, but what I mean by that is instead of these lifeless walls and ceilings and doors and windows, it works with you for the purpose, for the shared goal that you might have. And it depends on the building type, right? So if we're talking about, again, coming back to learning, we know that different people learn differently. So if the building knows what kind of a learner you are, and if you're in an informal or formal learning environment, maybe it provides the optimal environment for you to absorb and learn the most, right? Some people are visual learners. Maybe the walls turn into visual learning surfaces. Some people need absolute quiet spaces to be able to learn. Maybe it cancels noise, right? Some people need noise to learn. So that's one example, and it could be implemented to other areas. So I would like the future to be in a way that I say this a lot. I'm not sure if it's scary or not, but I really want to see buildings as my partners. I spend a lot of time in my office. I'm sure I'm not the only person. So if I think about the time I spent in my office or in a classroom or in a packing facility, whatever my job is, right? Sometimes I spend more time with my space than anybody else. And that space observes me and knows me, more than anybody else, because it sees my weaknesses, it sees my strengths, it sees good days, bad days, right? It's there if it has eyes and monitoring capabilities. So in a way, it is better than your best friend, maybe. So I'm sorry, I'm giving you a maybe very vague answer, but what I'm trying to say here is I would like to see buildings with personalities and buildings that work with you towards, for you to get towards these shared goals that you and the building might have. So going back to what we were talking about, right? So you thought that the building changes behavior, its colors, its surfaces, and temperature for the person. But I know as a fact that we change our behavior in different buildings. I'm not talking about any kind of technological building is in a building. So the way you work, the way you feel, your productivity, the route you're taking, and the way you're feeling safe or unsafe if you think about it, I think if you're conscious about it, you realize it in you as well, that we change our behavior in different buildings. Where we sit, how much we stand, and our memories are really shaped by space as well. Like you might feel happier in a certain type of space and less happy in another type of space. So this research that we're doing with Gail now, active shooter incidents, we're looking at how different building design options might be influencing people's behavior in case of hiding or evacuating in active shooter incidents. So we don't have results, but I have another research similar to this, and I do have results in this one. And we looked specifically in architectural visual access. So we did this experiment in a metro station in virtual reality, where there was a simulated fire, okay? And we had different versions of this train station. And in one version, we had this cluttered columns and thick walls, and you can see through, and lots of obstacles in your way to basically evacuate the station. In another version, we had a lot cleaner space, better lighting, line of sight, that you can see the clues of exits, like the ticket booths that you can see that you know that exit is behind those booths. And we looked at how people evacuate those two different spaces and how fast they evacuate and from which routes they evacuate. It is very different. Mm. So you can see your building, non-technological, changes your behavior. My research is very interdisciplinary, and I truly enjoy this. And it's challenging, it's not very easy, because if it's not entirely learning a new field, but you always find yourself in a situation you have to learn from the person you're collaborating with, and it's not always very comfortable. So I don't think I have imagined that I would work with so many different disciplines. I started with computer science, and I have very strong collaborations with computer science. Then, because of the human interest that I have, I work with social scientists quite a bit, and I love that. But depending on the type of the project, when we're talking about construction workers education, I'm working with people from School of Education. When we're talking about the desk and the intelligent desk, and one of the components which we didn't talk about is the ergonomics. I'm working with experts in occupational science. It is a very challenging task, quite frankly, to bring together different disciplines. I think the key there is finding a research question that you are all interested in. Without that, nothing happens. But there are many problems these days that many disciplines are interested in, and most of those problems cannot be solved by one discipline. So obviously I bring the building's perspective to the table, but there needs to be a person who is bringing the social and human behavior side. And there's computational side that needs to be there. But then you have to collaborate with other disciplines that are needed, right? We're talking about so many different types of buildings. So we're talking about educational buildings, you have to bring the educators. You're talking about health buildings, and you have to bring the medical professionals. To me, there's no other way, quite frankly. I mean, if you ask me if I can do a project, I have many ideas. If you're a solo project investigator, I don't have that idea. I have many ideas that require many people to come together. So it wasn't like this, but it became normal to me. It's the natural way of doing research. But I think as long as the group has a shared goal and passion for that research, it's a very rewarding experience.